Alright, Calculus 12. This is the lessons on asymptotes. Vertical asymptotes, horizontal asymptotes, and slant asymptotes. Are you ready to rock and roll? Woo! Again, getting stir crazy here, but it's okay. I'm talking to myself. My daughter's in the background in grade 4. She's getting a lesson right now on asymptotes. It's good times. So there she is. Alright, here we go. She's embarrassed now. Alright, so the practice for this is basically, I would have to say this is really pre-calc 12. The only difference is really it's just connecting it back to limits. So really you could fast forward through a majority of this video possibly and just kind of pause at the limit moments to kind of show the connection to where this is going. So this is the practice. I'm not going to read all that out. You could pause the video and write that down. I'll also have it part of the listing of the homework. So there's the homework that we're going to go through. Pre-calc 11, pre-calc 12, pre-calc 12, pre-calc 12, with limits thrown into the mix. All right, just the background things of things that you already know, but when it comes to vertical asymptotes and points of discontinuity from pre-calc 12, you know that comes from denominators equaling 0. So if I had a vertical asymptote at x equals 1, you know it has to have a factor of x minus 1 in the denominator. And to have a point of discontinuity at 7, you would know that it would have to have a factor of x minus 7 in numerator and denominator, which would then cancel or divide out, so to speak, and give you the trouble spot, but it wouldn't be an asymptote. And then to determine the rest of the values of where the graph would go, you would then make an XY table and find appropriate data. Now the good news with our calculus we're going to be learning in Chapter 5, we'll learn also how to get a better sketch without having to do a massive XY table like you did in pre-calc 12. That's where Chapter 5 is actually going, with first derivatives and second derivatives, as you'll soon see. Not in this lesson, but in future lessons. Horizontal asymptotes. Don't forget that horizontal asymptotes always, always, always come from the limit as x approaches positive or negative infinity. That's really important. And you know, as a quick tool from pre-calc 12, that you have a y equals 0 horizontal asymptote if the numerator degree, power 1 here, is less than the denominator. Right away, you know it's that. Now I'm going to go through an example to show you with limits y again, as a reminder of review of limits. And for one like this, where the powers of the numerator and denominator are the same, it's the quotient of the leading coefficients of the highest power, so 2/3 would be your horizontal asymptote. And that's how the function would react at positive and negative infinity. Slant asymptotes, remember that's when the numerator degree is higher than the denominator degree, and then you do long division to find the slant asymptote. And again, the example we do today will allude to the limits of why it's doing that. All right, so 2 examples, just to make sure you've got all this mixed together. This first example just says use limits to find vertical and horizontal asymptotes. Show how the function reacts about the asymptotes. And there's the function, which is again very pre-calc 12. You could totally do this question with pre-calc 12. The only difference is we're going to just throw limits into the mix, as we've also talked about in calculus. So vertical asymptotes. So vertical asymptotes, I know right away what I'd be doing to this. I'd be factoring the heck out of it. So I would take this, factor the numerator, and upon factoring that I get x plus 2 and x minus 4. My denominator, I would factor out a 2 and get x squared minus 1, a difference of squares. So I'd get x minus, or 2, x minus 1, x plus 1. So just make sure you're able to do that mathematics, which I know you can. No factors cancel, so this does not have any points of discontinuity, but it does have 2 denominators equaling 0, and that's when x equals plus or minus 1. So right away, we know that this graph, and I'll do the graph down here in the bottom corner, I know right away that at negative 1, and at 1, there's 2 vertical asymptotes. Right away. Done. Now what you need to do with your limits, which is very much like you did in pre-calc 12 just with XY tables, you need to see where the function, how it reacts about the asymptote. So if I'm on this side of negative 1, is it up here or down here? In pre-calc 12, what you would have done you would have done like an XY table, and you would have picked points that are really close to -1 on either side. So you would have went like -1 point, say 0.1, and then on the other side of it you would have plugged in -0.99, and then you would have seen how it reacts about there. What we're going to do with calculus, the only difference is you just do it with limits. It's the limit as x approaches -1. When you're approaching from this side, remember that would be from the left. So if I go back to the original, where it doesn't matter which function, I'll go back to the factored form. And really you're kind of you're going to evaluate this limit, you're doing what you did in pre-calc 12. You're just going to plug in -1.01 into this x, this x, this x, and this x. That's really all you're doing. Okay? So let's just do that one really quickly. If I plug -1.01 into here and add 2, that's positive. If I plug -1.01 into that, that's negative. So my numerator is going to be negative. My denominator, plug -1.01 into here, I get negative. Plug -1.01 into there, I get negative. So my denominator is positive times negative, which is positive overall. That's going to give me a negative value. All right? So that tells me that this must be approaching -infinity. And you would have here, you just would have got a negative large number. So right now, I know that that graph right here is down here. And then you just do the exact same thing with this side of -1, this side of 1, this side of 1. So really you're going to go through and do these 4 limits, which you could do mentally or numerically. Now, I'm not going to go through all of those, but that's just really going through this question 4 times over. So when you plug in -1 from the right, you actually find out it's positive infinity. 1 from the left is also positive infinity, and this is negative infinity. All right, and that would have been, so plugging in that value for this one here, I would have plugged in, say, positive 0.99. Here I would have plugged in 1.01 positive. And you end up with knowing the graph looks like this. So this is that's how it reacts. So when they ask you how the function reacts about that asymptote, there's how you show the reaction. Okay, so there's the limit spin. So that's your vertical asymptotes. Horizontal, in pre-calc 12 you would have just looked at this and said, I know the rule, oh, the power is the same, divide the highest coefficients. Right away with your pre-calc 12 you know that's 1/2. With calculus, to put the limit spin on it, horizontal asymptotes, you just literally approach, you take the limit as x goes to negative or positive infinity. And this is just a good reminder of how do you do a limit to infinity with a ratio of polynomials. And remember, this is a review of our first unit. Remember, going to infinity for a ratio of polynomials, you can't plug infinity in because you get infinity over infinity, and that could possibly lead to troubles. So you have to divide by the highest power. In this case is x squared. And you end up with, now I realize right now pre-calc 12 you'd be done, but this is just the y. So here you get 1, everything divided by x squared, x squared, x squared. You end up with this mess. The denominator, I end up with that mess. And remember, the whole purpose of this is as x goes to infinity, 2/infinity, essentially 0, essentially 0, essentially 0, and you end up with 1/2. So I know there's a horizontal asymptote here at y equals 1/2. Now, what the graph is doing, I mean, you would have to get more data to find out, like, is it doing this? Is it coming past it here? Because remember, you can cross horizontal asymptotes. Horizontal asymptotes can be crossed. And if you actually do graph this function, you actually end up with this. Now I did it with Desmos to cheat a little bit. You actually end up with this, which is kind of what you would be. But this one's actually interesting how this one actually comes up like this. it actually crosses there, but it does come back to the y equals 1/2. Now if you didn't know that, personally, if you had done this with Precalc 12, you might have just drawn it like this and not known it was there. But if you actually make this equal to 1/2, you'll actually find out that x is a value and it does cross. But remember, it's not about what's happening in the middle, it's what's happening at infinity. So hopefully that's a good reminder of skills you learned from Precalc 12 with the limits thrown in. So again, much of that is review. Just again, be really careful with your rookie errors and knowing your concepts. Okay, but very good review of from left and right limits and approaching infinity limits. Last example is the slant asymptote, which is, again, Precalc 12 wise. Let's just jump right in. You would look at this, and knowledge is power. You would look at that and go, rational function, higher power than the denominator. Right away, I'm like, boom, slant asymptote. Asymptote. I also know it has a vertical asymptote at 2 because there's a denominator of 0 at 2. But it's not asking that. It wants a slant asymptote. So right away, as soon as it wants a slant asymptote, I'm like, okay, I long divide. Okay? So I long divide. 2x minus 2 divides into x squared plus 2x plus 1. Just be careful with your rookie errors here. So x goes into that. X times, I get x squared minus 2x. I'm going to subtract. So this, take away that. Double negative is positive, so I get 4x plus 1. And then at that point, what's my next step? I need to add 4 because x goes into that 4 times, and I end up with 4x minus 8. Subtract. That gives me 9. And remember, the whole purpose of this question is I'm going to rewrite this function as, because now we've shown that this polynomial divided by that x minus 2 is equivalent to, remember, p over d equals q plus r over d. There's my quotient, x plus 4. My remainder is 9 divided by the divisor, which is x minus 2. So remember, quotient, remainder, divisor, polynomial. So now all we've done is rewritten this. Now you know from Precalc 12 right away, you just look at the quotient part and go, hey, my slant asymptote is y equals x plus 4. And then you go in to your little graph and go, okay, 1, 2, 3, 4. Do my slope of 1 up over 1. There's my slant asymptote. And then you would do your XY table to get more data. But now the reason why, which maybe you learned in Precalc 12, maybe you didn't, maybe you did learn it, but you don't really know why. The reason for this, remember, here's the calculus spin, is this is the limit as x approaches infinity still. If you do the limit of this function to infinity, it's the same as doing this function to infinity. So if I write this out, and I want you to look very carefully at that. As x goes to infinity, this part of the function, because the denominator is going to have an infinity or negative infinity into here, 9 divided by a massive number, positive or negative, this part of the function essentially goes to 0. And the function becomes line-like. So line-like at x approaching positive or negative infinity. So that's why in the middle here, the function's not going to look like the line at all, but over here, the function's either going to be approaching from top or bottom of that. We don't know yet until we get more data. But there's the math calculus reason why this works. Okay, so we'll leave it at that. That is it for asymptotes. The good news is, or bad news is, for the rest of Chapter 5, we're going to then be adding some calculus in there to make the graphing less intense from Precalc 12, so you don't have to do as much XY tabling. but it does add another element of dimension to it. So we'll leave you with that. Have a good day. Hopefully we'll talk to you sooner than later in person. If not, have fun with the math. Email me if you have any questions. Do it through either my school email, or feel free to even do it through the chat on the Teams. And if there's any questions, do not hesitate to get a hold of me. Phone me at home even. Doesn't bother me. All right, have a good day. Talk to you soon.